Welcome to FEA Insight and FEA Academy YouTube channel. Master Finite Element Analysis with our comprehensive series of videos tailored to both beginners and experienced engineers. Explore fundamental concepts, advanced techniques, and real-world applications through case studies and practical tips. Stay updated with the latest developments in FEA, empowering you to excel in your engineering career. Hi, welcome to this new episode of FEA Insight. Today we're going to talk about how to learn FEA, but also the advantages of learning FEA. Here is the agenda. First, I'm going to start with the 3 stages of the FEA learning process and the main rule of FEA learning. I'm going to present you what is the main danger of FEA and answer the question, what do you need to learn in the FEA field? Finally, I'm going to conclude this presentation by sharing with you my 10 guidelines for FEA learning and the 5 advantages of learning FEA. There are 3 stages for the FEA learning process. First, learning the basic FEM theory, learning proper modeling techniques, and learning how to use an FEA software. Engineers typically learn FEM theory in university or college before they learn how to use the FEA software. And all too often, they skip the stage 2, which consists of learning the proper modeling techniques. For me, such an approach is problematic because many FEA analysts make incorrect assumptions and generate wrong analysis simply because they are unaware of basic FEM rules. Good knowledge of proper modeling techniques will permit you to make the right assumptions and choices to accurately model and solve problems using simulation. And keep in mind that once you know the theory and proper modeling techniques, learning an FEA software package is the easiest step in the process. This leads us to the main rule of FEA learning. Learning FEA is more than learning how to use a software. It's more a matter of understanding the FEA process, acquiring the best modeling practices, and knowing the behavior of the system you wish to model. Unfortunately, and all too often, as I told you before, engineers try to learn FEA by attempting to use the FEA software before they understand the theory and proper modeling techniques. I strongly believe that learning FEA from a software perspective is a recipe for disaster. This is because FEA is not just about the software. It requires an understanding of the modeling process that permits you to solve physical problems. So the importance of the FEA software itself is very often overestimated compared with a good understanding of the modeling process. During my coaching with beginners in FEA, I realized that they focus on the graphical aspects over engineering data and modeling techniques. So what I want to suggest is always remember that an FEA software is just a black box for solving very complex systems of equations that cannot be solved by hand. And keep in mind that FEA is simply a tool used to help you in order to do your structural analysis. So, if you do not master the modeling techniques, you will likely submit an incorrect system of equations to the solver. But the problem is that the solver will give you a solution, even if your system of equations does not correspond to your problem. So, what is the main danger of FEA? I think you understand it now. The main danger of FEA is not knowing whether an answer given by the FEA software is correct. Always keep in mind that the FEA software gives an answer to a system of equations submitted by the analysis, even though the system of equations has nothing to do with the real problem. So to address this issue, you must follow the best modeling practices and use validated modeling techniques. You must understand the real behavior of the mechanical system you wish to model and be able to predict its behavior before beginning your modeling work. So it means that the most important quality you need before modeling a mechanical system using FEA is your engineering judgment. So let me presenting you 13 points that you need to learn in the FEA field in order to build reliable and accurate finite element models. First, you need to define an FEA strategy. I like to say that developing an FEM is like playing chess. You must anticipate problems, predict behaviors, and adapt your strategy. So, anticipating potential issues when building a complex FEM involving multiple connected parts is not easy. So, planning is the key. Without planning, you may encounter problems you will be unable to solve without diminishing the intrinsic quality of your model. So you have to adapt your strategy to each simulation, to each problem you will have to solve. You have to know the solutions available with your solver. By that I mean the capabilities and the limitations of the solutions available with your solver. You have to learn also the library of elements corresponding with your solver. We know that with the nodes, the elements are the key of the discretization in FEA. By discretization, I mean the meshing. So the elements you will choose to build your model will influence its behavior. It is why the FEA software publishers document the library of elements associated with their solvers. The capabilities of each element need to be understood by the analyst in order to select the right elements corresponding to their need. Personally, when I change my FEA solver, the first thing I do is to read the documentation related to the library of elements in order to know the capabilities and the limitations of each type of element. Then you will have to learn how to perform meshing. The global FEM to capture global effects or detailed FEM to capture local effects. It is something fundamental that you have to learn. To be able to create a discretization, the meshing, compatible with your problem, you will have to learn a lot of things, okay? Define a meshing plan, select the appropriate elements types to properly represent the behavior of the structure, apply the proper mesh refinement, conduct the mesh convergence study, create the mesh transitions, perform the mesh quality checks, choose between 2D and 3D meshing, and even 1D, and choose the element size. Also, you will need to learn how to define the right boundary conditions. By that, I mean the constraints and loading. It is one of the most complex problems you will have to solve as an FEA analyst. You have to know that the boundary conditions influence a lot the results. But keep in mind that the FEA solver will give you a solution in most of the cases, even if you choose the wrong boundary conditions. So defining the correct boundary conditions ensure that you submit the right set of equations to the solver. I mean the equations which correspond to the reality. Also, you're going to have to learn how to choose the right material models. And many materials models are available in the FEA software. Also, you will have to do assumptions about the connections among parts. Because most of the time, we use finite element analysis in order to solve complex problems And in these complex problems, we have different components in the simulation. And these components, these parts, they are connected together by bonding, by fasteners, by different technologies. So you will have to learn how to model these connections. You will have to learn how to perform the validation and the correlation of your finite element model. This is very important because it will give you confidence in your results, but also to your client and the final user of the FEA. There are methods available to validate your FEA, so learn them and use them. If you work with test data, you will have to learn how to correlate an FEM and how to adjust and calibrate your simulation. You will have to learn also another thing to learn is the understanding of the outputs provided by the solver. There is a large variety of results you can extract from a simulation. You will have to learn how to interpret them and how to make sure that they correspond to what you are looking for. Moreover, many options are available in the FEA packages to extract the results, and each option can significantly influence the results. By knowing them, you will better understand the outputs of your simulation. You will have to learn how to perform submodeling. You have to learn submodeling because it is a modeling technique which permit to build very detailed analysis in a particular region of a model without the need to refine the whole model. This is a very powerful technique. You will learn also the concept of optimization of the performance of your FEA runs. For each FEA software, there are parameters in order to optimize the performance of your simulations. Learn them. I strongly recommend you learn also about the architecture of the computers you are using, the personal computers, the HPC, the cluster, and so on, because it will help you optimizing your running time. You will have to learn how to document your FEA. Learning how to document an FEA is important because from an industrial point of view, an FEA and its associated results must be traceable years after the project is completed. Most FEA documentation today focuses mainly on the results, but these results are influenced by many parameters. So all the assumptions of the simulations should be documented also. So an FEA documentation has many purposes. First, to present the assumptions you did to build your simulation, to track the data used to perform the FEA, to provide a basis for further analysis, to permit the FEA analyst to replicate the analysis, but also to permit training and also to establish in-house expertise in FEA. And finally, learn and follow the best FEA practices. Now let's go through my 10 guidelines for FEA learning. For a mechanical engineer, FEA is one tool that is well worth the effort to learn. Here, I want to provide you some tips that will help you in your learning process. First, for the structural analysis of mechanical systems, a strong background in engineering mechanics, including calculus, statics, basic dynamics, and strength of materials is required. Take classes in basic FEM theory. The better you know the basic theory, Take classes in FEA theory. The better you know the basic theory being processed by the software, the more you will perceive the underlying limitations of the solutions. For sure, you will not develop an FEA software or a new element, but as an engineer, learning the basic theory of FEA will permit you to understand four things. First, how the stiffness matrices are computed for various topologies of elements, how the global stiffness matrix of your system is assembled, how the solver computes the equations to obtain the primary variables, the displacements in mechanical structural analysis, for example, and how the solver computes the secondary variables, the forces, the stresses, the strains. At the end, knowing the basic theory will help you to take decisions during your modeling process, because even if you will not solve the equations yourself, this knowledge will permit you to make the right assumptions. Do not begin with software. Learn FEA. The software permits you to build and examine models, but it is dangerous to use it without understanding the underlying concept of modeling. Whatever software you use, the modeling techniques remain the same. Moreover, in the course of your career, you will probably change software packages several times. Understand the behavior of your model, okay? Or of your problem, I should say. Keep in mind that FEA is not used to predict the behavior of your mechanical system. You must do the opposite and be able to predict the behavior of your structure to build a reliable and accurate FEM. Your engineering judgment and ability to predict the behavior of the system are fundamental. Always try to understand things in depth. In the beginning, it takes time to understand the FEA process. However, there will be a profitable return on investment later, because by deeply understanding what occurs in one problem, you will be able to solve similar problems in the future. So, to understand FEA in detail, you need to go beyond the tutorials prepared by the software distributors. Such tutorials typically explain where to click to obtain the results of simulation. By following such tutorials, you will obtain answers. You will press the computation button and likely obtain the results without ever seeing a single error message. But you have to know that this approach will not make you a real-world FEA analyst. Start with simple problems. It is always best to start with small, simple problems. A building block approach is an efficient way to learn FEA. So, studying simple problems initially allows you to truly understand what is going on, so that you can eventually solve complex problems faster. The short runtime of a simple problem is another advantage. With a simple model, if any part is incorrect, you will not have to wait long for the results or an error message. You will be able to fix it quickly and iterate rapidly. This will speed up your learning process. So don't use complex problems to learn FEA. Use simple problems. Take FEA training classes. FEA training class instructor, Take FEA training classes. FEA training class instructors are often specialists in the field, and they can provide a lot of practical knowledge. FEA training classes teach you much more than which button to push to create a solution. These classes will teach you the modeling techniques that you will be able to use for any problem you will face in the projects you will be involved, and independently from the FEA software. Practice, practice, and more practice. Let me tell you the words from a trainer at the end of an FEA class. You have two choices. Practice what you have learned, or I will see you next year for a repeat of this training course. So practice, practice, and practice. Join users groups and attend any FEA seminars available. Users group, both online and in person, are a great way to learn from your peers. So I strongly believe that other people are the best source of knowledge, and many more people than you think want to share their knowledge. Believe me. So attending FEA seminars will also you help. And finally, be patient. It takes time to learn FEA. There will be a lot of trial and error before you reach the point where you feel confident about what you are doing. If you start from scratch and use good resources, it will usually take about 3 years to learn the basic knowledge. Add 5 years to learn the advanced knowledge. But it doesn't mean that after 8 years, you will have nothing to learn. FEA is a field that is rapidly evolving. Even after 8 years of practice, you will still be learning new things about FEA. FEA is complex, so take it one time at a time. FEA is complex, so take it one step at a time. FEA is a very powerful tool that looks incredibly simple from the outside, when in reality it is not. FEA is complex and there is a lot to learn. Again, keep in mind that FEA always provides a response, even if it's an incorrect one. So, if you don't have strong FEA knowledge, you may not recognize inaccuracy in the result. And you have to think of FEA as a calculator that is difficult to use. So take your time, acquiring the necessary knowledge for conducting a good analysis, and you will be able to simulate and solve all the engineering problems you want. Before to go to the advantages in learning FEA, let me present you the wheel of FEA structural competencies from the Boeing company. Here on this graphic, at the middle, in orange, you see different structural design criteria. For example, linear static analysis, fracture and failure mechanics, parametric CAE optimization, nonlinear geometric analysis, nonlinear material analysis, vibration and dynamic. They are the structural design criteria you need to analyze. With each criteria, you have different competencies that you have to learn. And you see there are many of them. For example, for linear static analysis, you have meshing, the selection of the element types, defining the boundary condition, apply loading. For nonlinear geometric analysis, you have the large displacement concept, the post-buckling concept, the stability concept, and the multibodies. For nonlinear materials, you have creep, viscoelasticity, plasticity, nonlinear elasticity, and so on. So you see, it's a lot of competencies associated with each criteria. You have to know that for one engineer, it's impossible to learn all of them. You will have to select some of them. Let's conclude this presentation with the 5 advantages of learning FEA. First, learning FEA permits to solve complex problems. The main advantage of learning FEA is the fact that you can solve problems that are impossible to calculate otherwise. This is because end calculations are only valid and accurate for very simple problems. However, as a mechanical and structural engineer, you will rarely be faced with simple problems. Advanced designs are so complex that classical methods, such as end calculation, will not permit you to meet the objectives. You will have to do finite element analysis to solve these complex problems. Learning FEA gives you an edge over other engineers. Learning FEA gives you an edge over other engineers because instead of using conservative assumptions to make an inaccurate end calculation work, you can simply use a computer to conduct FEA, capture the real failure mode, and compute the critical parts of your design in a multitude of different configurations. Moreover, with FEA, you can find solutions to problems driven by various phenomena, such as elasticity, vibration, stability, plasticity, interaction between parts, and etc. So by mastering FEA, you will be able to develop better products for a fraction of the cost and time. Learning FEA in detail permits you to avoid its dark side. Yes, FEA has a dark side. The first aspect of this dark side is that it is very difficult to find errors in complex FEMs. So learning the verification process will help you to retain control of your models and give you greater confidence in the results. The second aspect is that FEA can be used to prove wrong results by making bad assumptions. In my career, I have seen many professional presentations based on incorrect FEAs that succeeded to convince people that the results were correct. So by learning FEA in detail and mastering the modeling techniques, you will avoid such pitfalls and you will be a better FEA analyst. Another advantage of learning FEA is the fact that FEA improves your versatility. The flexibility of FEA is such that it can be used in various applications. An engineer with very good knowledge of FEA is much more versatile than one who does not know it very well. So, since the modeling techniques are universal, mastering FEA will permit you navigate various types of industries and work on different projects all over the world. To conclude, I want to mention that everybody can learn FEA. Just follow the 3 stages in the right order. But please don't miss the step 2, learn the modeling techniques before an FEA software. The last thing I want to share with you is that with FEA, you will never stop learning something. It is the beauty of this discipline. For me, learning something is the most pleasant feeling I have every day. I cannot live without it. I strongly believe that we should be taught every day. And it is not a matter of being right or wrong. It is a matter of being open-minded and having enough humility to admit that we can't know everything. If you want to learn more about FEA, feel free to contact me via email or on LinkedIn. If you want to learn FEA in detail, I recommend you my book, Practical Finite Element Analysis for Mechanical Engineer. It's more than 650 pages about the finite element analysis best practical methods and guidelines with more than 100 examples. It is available on the FEA Academy website. And also, I propose you my online on-demand courses. I have the basic course, in 17 lectures plus 14 FEA workflows, more than 20 hours. I have also the practical nonlinear course in 15 lectures and 17 FEA workflow in 12 hours. All that on demand, in video, online. And for sure, the famous bundle course, which englobe the basic and the nonlinear courses. See you to the next FEA Insight episode.